welcome back to my channel Simple Engineering with Practical Examples. So this is the final video of the series of Welding Imperfection and Defects. As you remember that in first video we discussed about the cracks. In the second video we covered cavities, and now in this video we will discuss about remaining welding defects, which includes solid inclusion, lack of fusion and penetration, and imperfect shape and dimensions, right? So let's start with solid inclusions. Solid inclusions are solid foreign materials which is trapped inside the weld metal. Solid inclusions are classified into four categories, starting with number one is slag inclusion, number second is flux inclusion, number third is oxide inclusion, and the last is metallic inclusion. Let's understand slightly in detail for every type of solid inclusion. So slag inclusion is a solid inclusion in the form of slag. So it can be linear, isolated, or clustered. You can see in the photograph, first photograph, it's a linear slag inclusion, and in the second one you can see it's a isolated slag inclusion. Next one is flux inclusion. Okay, that is also a solid inclusion but in the form of flux. Right? You can see in the photograph, this is how the flux is embedded into the weld metal. Third is oxide inclusion. That is also a solid inclusion but in the form of metallic oxide. So there will be a layer of metallic oxide. You can see in the photograph for more clarity. And last one is metallic inclusion, and they will come into the picture when the foreign metal is entrapped into that. That foreign metal can be any metal, tungsten, copper, or any other material. Lack of fusion is lack of union between the weld metal and the parent material, or between the successive layers of the weld metal, as we are carrying out the welding in different layers. Right? So the lack of fusion can be of different variety, starting with lack of sidewall fusion, lack of inter-run fusion, lack of root fusion, or micro-lac fusion. So you can see in the photographs for the different examples, right? Now the next is incomplete penetration or lack of penetration, right? So incomplete penetration is a difference between the actual and the nominal penetration. Right? Next variety is incomplete root penetration. When one or both fusion faces of the roots are not melted, then it resulted in incomplete root penetration deficiency. Right? So you can see into the pictures for more clarity. There is another type of imperfection which is called spiking, which is extremely non-uniform penetration, which is occurring in electron beam and laser welding, which gives a feeling of sawtooth appearance. Right? So you can see into the photograph how it looks like. This can include cavities, cracks, shrinkages, but you can see how it looks like. Now the next variety of the imperfection is imperfect shape and dimensions. Right? So imperfect shape is a shape of the external surface of the weld or defective joint geometry. Right? So these can be in undercut. Right? Undercut may be of very different type. The one may be continuous undercut. You can see the example, right, where the irregular groove at the toe of a run in the parent material or in previously deposited weld metal. So there will be continuity. Similarly, there will be a continuous undercut, where undercut of significant length without interruption. So you can see the two photographs for clarity. There are intermittent undercut also, where the short length of the undercut is appearing on the weld metal. Refer to this photograph. There are shrinkage grooves also. This is again a variety of the undercuts which is visible on each side of the root run. Interrun in the undercuts are also we have witnessed, where undercut in the longitudinal direction between the weld runs. Next type of imperfect imperfection is excess weld metal. Excess weld metal is a reinforcement of the butt weld on the face if it is too large. As you can see in the picture, that hump which is there, right? Now next is excessive convexity. So it is the reinforcement of the fillet. If it is too large, then it results into the excessive convexity. You can see into the picture. Next one is excessive penetration, and if it is the reinforcement of the butt weld on the root side is too large, then it results into the excessive penetration. So this can be local excessive penetration or continuous excessive penetration or excessive melt through penetration. So you can see in the photograph for excessive penetration. Right? Another type of imperfection in the weld is overlap. Overlap is the excessive weld metal covering the parent material surface but not fused to it. So there are different types of overlap. Naming some of them are toe overlap, root overlap, and you can see into the picture both the examples. Right. Next one is linear misalignment, and these misalignment happens when two welded pieces such that they are not in the same plane but required parallel plane even though their surface planes are parallel. Right. So this can be linear misalignment between plates or linear misalignment between tubes. You can see in the picture how the angular misalignment looks like. There is another type of imperfection which is called burn through, which is a collapse of the weld pool resulting in a hole in the weld. So you can see in the picture big holes which are happening. Next one is incompletely filled groove, which is a longitudinal, continuous or intermittent channel in the surface of a weld due to insufficient deposition of the weld filler material. Right. You can see in the picture for the clarity. There is another type of imperfection which is called irregular width, where you can see that excessive variation in width of the weld is occurring throughout the length. Right, so this also you can see in the photographs for clarity. There is another type of imperfection which is called root concavity, which is a shallow groove due to shrinkage of a butt weld at the root. You can see the photograph. Root porosity is also a deficiency, which is a spongy formation at the root of a weld due to bubbling of the weld metal at the moment of solidification. There are poor restart also, which is a local surface irregularity at the weld restart. So it can occur in the capping run or in the root run. You can see in the example. There are excessive distortion also, which is a dimensional deviation due to shrinkage and distortion of the welds. Right, and that shrinkage happens when the welding is or the weld is getting cooled. Now let us see different miscellaneous type of welding imperfection or welding defects. There are arc strike or stray arc. You can see into the photograph. These are the local damages to the surface of the parent material adjacent to the weld, resulting from arcing or striking the arc outside the joint preparation. Spatter is also another issue where the globules of weld metals or filler metal expelled during welding and adhere to the surface of a parent material or solidified weld metal. There are examples of torn surfaces also where the surface damage due to the removal by fracture of temporary welded attachment. Grinding mark, many times we have seen the welder gives or do some of the grinding on the parent material, so they are also local damage to the surface. There are some chipping marks also observed as a deficiency or defect. They are the local damage due to the use of chisel or other tools. You can see in the photographs various examples, right? So that's it. I believe that now you are clear about all types of welding defects, and in my next video I will cover welding safety. So stay tuned with us, and if you like the channel you can also subscribe, share and like. Thank you very much.